everyone. So I just wanted to do a few videos on the arrow pushing of mass spec. There's a lot going on. You got some half arrows, you got some full arrows. So I just want to make sure we're all on the same page on how those work. So I'm going to start off with our alkyl bromides. So these are pretty straightforward because alkyl bromides are only going to do one type of fragmentation, and that is going to be our heterolytic cleavage. Right, so our heterolytic cleavage is going to be where we are going to be using our double barbed arrows where two electrons are moving at one time. So don't forget, before we ever start fragmenting, we're going to form our molecular ion, and that is going to occur by losing one electron from bromine's lone pairs. So we are going to form this species, it doesn't matter which one, where we now have our molecular ion. And I usually go ahead and determine what the mass to charge ratio of this species is, because I know that's going to be the largest mass on my mass spec. And then also, this is going to have two peaks, right? Because we do have bromine on this fragment, so I need to account for the isotope of bromine where I know I have a 1-to-1 ratio for that abundancy, since the abundancy of bromine 79 and bromine 81 is 50-50. All right, that was a lot of information really fast at you, but this is just for our arrow pushing, not talking about the entirety of mass spec. So for our heterolytic cleavage, the way I'm going to push those arrows is I am going to break the carbon-bromine bond, and the bromine is going to get both of those electrons. So the fragments that I form is I have those 3 carbons that were here. Well, that carbon lost a bond, so it now has a positive charge. So I have a carbocation. Then I have my bromine, which has now picked up a lone pair from the bond, but it still exists as a radical, and it is neutral. If you go through and calculate formal charge, you will find that bromine does not have a charge here. And so our mass spec is only going to see the carbocation since it has the positive charge. And so the mass to charge ratio for our propyl group is going to be, let's see, I got 3 carbons. 3 times 12 is 36. Then I should have 3, 5, 7, yep, 7 hydrogens. So I'm getting 42 for my propyl group. So my mass to charge ratio should be 42. All right, and then we would look at the mass to charge ratio for molecular ion peak as well. And so we would just do the same math. So I have 3 carbons. That would be, again, 36. Bromine has a mass of 79, and then I have, let's see, 3, 5, 7 hydrogens. Okay, I can't do that one in my head. We're going to have to pull out the calculator. All right, so we got 36 plus 79 plus 7. Okay, I'm getting 122. I don't have a room full of people to tell me my math's bad, so hopefully that's right. We'll find out. I have the spectra. All right, and then don't forget the isotope of bromine. So the isotope here was 79. The other isotope for bromine is 81. So that's just going to add 2 to my molecular ion peak. And then because of the fact bromine is not in the carbocation, I do not have to worry about any twin peaks or an isotope peak here. All right, so that's all the fragmentations that I could come up with. So these would be the 3 numbers I would look for in my mass spec. So let's take a look. All right, so, okay, good, that was pretty good. Yeah, so I have my 1, ooh, you can't see that because it's light and we went to a white background. Okay, so we have 122 here, here's 124. So I do see those 2 twin peaks that are exactly the same in abundancy. I usually call them twin peaks. All right, and then I have my, okay, so I was off by a hydrogen. Dagnabbit, those hydrogens. So I should have had 3 here, 5. What did I do wrong, guys? I need you guys here to help me. Let's see. Somehow I'm off by 1. It is 43. It normally is. All right, so propyl should have 3, 5. That's 7. Maybe I just did my math bad. You know, let's put in the calculator. I bet you I just added wrong because I can see a 6 and 7. That should be a 3. 36 plus 7. Oh my goodness, that's embarrassing. All right, 43. There we go. Now we're cooking with gas. So here's the 43 from that propyl group. All right, and then, yeah, sure, we're going to have the other fragmentation patterns that we would talk about with an alkane. So 2, 3, bromine. Sure, we could lose a methyl group. That's where 15 comes from. Or what we could do is we could lose an ethyl group. Okay, fine, that's where 27, and so on and so forth. But the peaks that I would look for to figure out if it was bromine would be that twin peak and also the heterolytic cleavage. Okay, so hopefully that brought some clarification for bromine.